First off, this fully conditioned, the zone conditioning, if you want to have an outdoor zone, let's say some outdoor lighting, outdoor pumps, maybe you have an outdoor pool, then you can make this an exterior zone. And if you do that, then you probably don't want it under a system because there's no air handling happening there, right? So then you could just cut it, not delete it. You cut that zone, and then the zone's still going to be around. Okay, I'm going to move this zone up here. So now I have two identical zones. They're both classrooms, and they're both being served by air conditioning systems, but I also have a third zone, which is outdoors. That must be this one right here. More on the zone form. A lot of this you can figure out yourself. Actually, all of it. In the detail form, these are your dead bands. What we mean by dead bands is if I have a set point of 72 degrees and the temperature goes 72 minus 8, which would be 64 degrees, then it starts heating. So that's what this dead band is at what temperature do I not cool but actually start heating. In the winter case, if my set point is 70 degrees and then it makes it up to 75, then I would start cooling. There's loads just like with the system. The supply air form is interesting because here's your 55 and 110, and we saw this before. That was in the system detail form. Let me find this detail 55 110. Well, this was 110, and you might ask, or I certainly asked, why do we enter in this in twice? This is dumb. Well, there's a reason. That is, if you think of the equation for just about everything in HVAC, it's Q equals 1.08 CFM delta T. Q is this. Delta T is the indoor temperature, so that this is the zone temperature, minus the supply air temperature. That's my delta T. So I have Q, I have my 1.08, I have my delta T. The only thing left is CFM, and that's what we're calculating in this form, is what is the zonal CFM requirement. Well, for cooling, it's that, 12,000 and something, and for heating, it's 6,500 and something. And then it will also look at your minimum ventilation. Now, the minimum ventilation comes from, it's actually calculated here, but there's some use defaults which we haven't been looking at yet, but this will help us determine our ventilation. So it's taking 0.38 CFM per square foot times number of square feet, and that will calculate your minimum ventilation. So it's looking at those three, and based on those three, it will take the largest of those. So there's this, that, and that. The largest happens to be cooling. That's how the zone supply air form works. So for each zone, it'll determine what are the CFM requirements. Then, at the system level, it'll add all the zones up if there's more than one zone in a system, and then that will be the CFM requirement or the fan sizing requirement. If you're letting Market Manager auto size it, or you want to know the default, it's just going to add all of these up together. Now there's one place where you can run into trouble here, and I've seen people run into big trouble, and I want to show you that. If you were not auto sizing out the zone air, I suggest that you do auto size it, but let's say you weren't, then what you could do, supply air, is, see, now this isn't being calculated, right? What if you went and changed this and you decided, well, I think in the wintertime we need to heat to 75. Now I doubt you do that, but I'm going to do that anyway. I go back to supply air. See, this is now a larger number, and let's do some more changes. This is zone 3. I'm going to add in zone 3, I'll change the wall R values to 1 and all. I'm just going to do something ridiculous. I'm just going to add a lot of load here. So hold on a second. I want to go back to zone 3, and now if I go back, you'll see that my supply air requirement is 251. And that's a lot larger than this. Now, because I'm not auto sizing it, what will happen is people will, they won't go and look at this form. They just don't do it. And Market Manager will assume this is the right number, even though it's not. And then when they're sizing their fan, here, let's go take a look and see the fan. So I go back, open up the fan. It will assume the CFM based on what you had in that zone form, which is 12,000. Well, guess what? That's way off. And then if you're doing a model trying to, estimate energy savings or something, you're totally wrong. In this case, then, I want it to be the maximum of those three. Then you can look at the fan and you'll see that the supply air is now higher. Okay? So, the general rule is you should auto-size zone air. Okay? There's another way around it. If you choose not to auto-size zone air, what you should do is if you know what the zonal air requirements are, you can look at the mechanical drawings and you know what they are, then go ahead and put those in. It'll take a little more work, but you can do that as well. That would be just fine. Okay, and then you would put those, of course, right here in the zonal supply air. If you have a VAV system, then your minimum VAV stop is going to go right here. We don't have one, that's why it's at 100. Okay, that's it for the zone form. Let's go to the air cooling form. This is your capacity, how many tons. It's being auto-sized, so I can't get in there. Otherwise, I could type in a number. Your efficiency. The main thing I guess I want to talk about is the part load ratios or part load ratio coefficients. And that's what these are. So this would be A plus BX plus CX to the third plus, CX squared plus DX to the third. Okay, so these are for your part load. Also, performance variation. You can get this information from cut sheets. We recommend that you do get it and put it in. I know that generally people don't do it, but you should. The heating form. It's pretty simple. You can figure out all of this, but in detail, this part's really important. The heating for, that's very important. So, is the heating for heating the space, for humidification, for preheat, reheat? The main thing is if you have a terminal reheat system and you don't have this reheat selected, the program will actually, and if no heating item has reheat selected, it'll give you the reheat for free, and you'll be completely underestimating your energy usage for heating. Okay, if you have a preheat and this isn't selected, you're getting it for free. So you really need to be careful about these. And it's not just going to magically do it for free and not count it. You'll get a message that says, I'll just do it and get you the message. So this is a terminal reheat, good. So if I simulate this, it's going to say I have unmet heating hours, and that's because one of the reasons is because I'm not doing the reheat. And this is a terminal reheat. Okay, so it'll tell you that at least. Let's see, I'm going to add a chiller. Let's see, new chiller. Chiller, is it air cooled, is it evaporatively cooled, or is it both? You can check on those. In the detail, there's a couple tricks here. This is not the temperature the water is actually entering and leaving. This is the rated temperature in the cut sheets. So this doesn't mean that it's actually operating at 44. Maybe it's operating at 42. This is just what's from the cut sheets. So, but that's of some value. And then this is your pump power. This is your chill water pump, or all your chill water pumps together. And this is your condenser water pumps. If you've got an air-cooled chiller, then this would be your condenser fans. Okay. If you've got, here, let me quit auto-sizing the cooling equipment and go back to the chiller. If you have, let's say, all your pumping power is on variable speed drives, then you might put your kilowatts here. So this just means that it's on variable speed drives. If it's a primary secondary system, then this is your primary, which is on constant speed or constant volume, and then this is your variable speed there. Okay, here's your fan control or pump control if you want to cycle it or always on, And again, if you don't know what they mean by this, it's just Shift F1 and it'll explain what they mean. There is some TES stuff if you want to do that. One thing I didn't really go over was fan schedules, and I guess it's time to do that. A fan schedule. Now the way this works is it's saying the fan's on all year, Monday, all days, and it's saying that it turned on at 9 o'clock and turned off at 5. That's what that says. So 100 means 100%. There's something called HVAC summer. What that means is those are the months that are defined as summer in the system form. Remember, we defined what summer was. That's May through September. Okay, so that's what HVAC summer would stand for. I think that's it. The schedules aren't that hard. Again, if you wanted to do things quick, you just type in a number and then you press tab, number, tab, number, tab. If you wanted to know the default, here, let me put some of these numbers in and then see how they're italic because they're not default. You can press F9 and then tab to go to the next field. Okay, so F9 is the same as doing this thing. It's just a lot faster. Okay.